Hey, what is up guys? Welcome back to the chess game tutorial, the multiplayer chess game tutorial. In this episode, we actually create the flow we want. So we actually create the communication in between the server and the client for the moving of the player, for moving the actual pieces. As you can tell right here, we're going to have a host on the right hand side, why not, and a player just connecting. Once we connect, they are actually both being sent to the game screen. One of them is the host is the white player, so in this case this is the host. This one is able to move, the other one can't. We move, and as you can tell, the movement is being replicated. Now on this side, we're the black player, we're able to move, and it just works both ways. So it's really cool, and we get to do that today. So guys, without further ado, let's get right into it. Okay, so we've done most of the architecture going behind the server and the client. Now at this point, what we have to do is actually create our own kind of messages we're going to be sending. So let's just say that whenever somebody connects, we are the server, we can intercept that. So whenever that person connects, we send him a message, something like, who exactly are you? Then the client receives that message, he replies back with its name, and as soon as the server gets the name, he can say to everybody else connected, this person has signed in. So we're going to start with this simple back and forth communication here. So let's go at the very start point of this message, and that's going to be in the server. So because the server is the one that, that detects when somebody connects. So if we go under server, and for some reason I have some error here, let me just fix that. Okay, that should be the one. On incoming data, that's not it. Is connected, that is not it either. We're looking at accept TCP client because this is where somebody has connected. At this point, we still don't know like if that person has a client name, if that person, all the information we have is that a new socket has just, it's now installed with the server, so there's a new socket to talk to on the server as well. So over here, there is actually two things. I only mentioned one, so I was only saying that, okay, so the server should say, who are you to that person, but at the same time, we should actually send a list of all the users that are currently connected. So if the client is like the third client to join, then he can be up to speed with everybody else in the room. And I'm just going to call this room from now on. So when people connect to a server, let's just say that they are in some kind of room. As soon as that person connects, we are going to ask him, who are you? But at the same time, we're going to send information on who's here with us, so who's in the room. Let's actually go ahead and do that. So at this point, this is where we create our own messages. Now remember, we have a function down here that is called broadcast, and it broadcasts a simple data to pretty much everyone in the list. Now what we want to do here is only send that information to a single person. Now that single person is going to be the client itself, so SC, or if you prefer, we can use the last index of client. So let's go ahead, the data is going to be something we don't know just yet, and we're sending that message to, let's say, clients at the index clients.count -1. So we're sending it to the very last index, the very last client that just connected. Unfortunately, our function does not take in a client, it takes in a list of client. So what we could do is just put that in a list, or what I would rather do in this case is create an overload for that. So I'll just copy this, and we're going to paste it down here. Keep it the same exact name. We're going to be creating an overload. So simply change this for a simple client. I'll just call it C in this case. And what we're going to do in here is we are going to create a new list. So a new list of server client. And that list is going to be equal to a new list with only one instance, so only C. Basically, we're just creating a list that has only one index in it. And then with that list, we're going to call broadcast with the same data, and we are going to send our list. So just a simple overload that just puts our single client into a list, then calls this function. Okay, so that's what we're going to be using here, and our function now works. Right, so what kind of information do we want to send? We said that we want to send a message that says, who are you? And also, here's all the users. Now, you just gotta be finding your own way to actually format that. Now I'll show you how I do it, and if you want to create some kind of other encryption, we could say, then you just go ahead and do that. I'll start with whoever is sending that message. So in this case, it's the server, so I'll just capital S here, and the message I'm going to send is who, as in who are you. Okay, so the S who is going to take care of the message, like sending a message, who are you, and then after that, I'll create a pipe here. After that, this is where I want to send the data about the user. Now, let's create a string up here. Let's do a string all users is equal to empty for now, and then let's do it for each. So for each server client sc in client, so for every single client we have, let's actually add that up to our string. So all user plus equal client name. So we're gonna send the client name, and then let's create another sign, another special character to just split them apart. All users plus equal to, we're just gonna send the client name for now, and if we need some more information, we can actually add more here. So client name, and then once we're done, we are going to add a pipe sign. So in the end, what we're gonna have is a message that says HESU, and then pipe, and then client name, pipe, another client name, pipe, another client name, and so on. So what is the problem here? SC already exists, that's right. Let's use something else like why not? And okay, so that is definitely going to work at this point if we just do a plus all user. Okay, so after looking at this for a little while, just realized that this is not supposed to be called at this point. We need to actually send, we need to actually create our list before we add this, because we're pretty much just adding ourselves to the list and we don't have a name just yet. So that's kind of, that didn't really work out. So like this is gonna work a little bit better. So this is the very first message we get. Actually, we send. The first message we send is a HESU, and it's going to be sent to a single client. Now this message, we are going to receive it in the client in the function called onIncomingData. So this is where we get our information. Now at this point, this is where we are going to start. We're just going to start parsing things a little bit. So we're going to be like, you know, splitting our string, just doing all that kind of stuff. And we are just going to get started actually. Let's start by creating a array of string. A data, doesn't really matter the name you give it. And we're gonna split the string every time we see a pipe. Now this way it means that we can switch on the very first message, and the very first message is going to be like the general command, so what exactly is happening, and then afterward we can send some more parameter. So let's try with the first case. First case would be SWho. This is what we've done to actually have the message who is connected. And then in the HESU, we might receive some more parameters at the end. For int I, we're just going to iterate through those parameters. We're going to start at I1. You'll see why in a second. A data.length, -1 again, I++. So, a data at the index 0 is the command, so it's the SWho. So pretty much for the rest of the index we get, it just sends us the name of a user who's connected. So right now we don't really have anything, we don't have a function that just says user has connected. So I think we are going to create one actually. So let's go down here, do a private void user connected string name for that client's name. And inside of a user connected, we can create a new game client, C, call it, say, and then we're going to assign the name, so c.name is equal to, say, name. And then we have to decide if it's a host or not, depending on this. How do we check if it's a host or not? That is a very good question. If we receive it, well, first, let's add a parameter here. Let's just do a boolean host. If we actually get it from the SWho, it means that it is not a host. So user connected, the name is going to be a data at index I, and then afterward we'll do false because it's not a host if you get it from this function here. Okay, so we got this working. Then what else? Let's actually add those to a list so our client actually knows who's connected at all time. I'll go at the very top of my client, and we are going to write down a list of game clients. So a private list, a list of game client, and let's just call it players. So those are all the connected players basically. We don't seem to have list just yet, so let's go ahead and add the system.collection.generic here, and we're going to initialize it right here as well. Okay, so user connected, let's go back here. Once we've created the definition of the game client, let's just add it to the players. So players.add, and we're gonna add C. Okay, so we're almost done with the very first command here. This is who. We are checking for, well, we're receiving information on who's connected, then we connect them if there is, and after that we're gonna be sending the server back like a message like this is who I am. So we're gonna use our function called send. The message, the comment is gonna be see who, and we're gonna add the client name to that. So then the server is going to receive that message plus the client name, so it's able to actually identify who it is that just connected. Okay, so let's quickly give it a try so we can see it in action. I'm pressing on the host here, we get a message that says see who, and the person, the client name, is actually host. And now this is not going to work here, let's just debug.log data. But yeah, it is working actually, so we can just leave it like that. However, at this point we receive the information, well, we receive a message that says see who. Okay, so at this point we receive the message see who, and then it has the name in well, in the data. Let's actually go in our server and start parsing this a little bit. I'll quickly just grab in my client right here, just grab this information. We're going to be using the same exact method we've been using. So we split the string, that is fine, and then after that we are going to check for the first case being see who. So if we get see who, that means there is a client talking to us right now. The client is C. Remember, we get this as a parameter. So we get his name, we say c.clientName is equal to a data at the index 1. And at the same time, since we're now able to put a name on the client, we can broadcast that to everybody and just say, well, you know, this person has just connected. So let's use our broadcast down here and say something like SCNN for server connection, maybe something like that. Depends on what you like the most. And then we're going to send information about that client. So that client is going to be the client name, and we're sending that to all our clients. So just type in clients like that. And I think that is pretty much it. At this point, we go back in the client, and the client now gets a new message. The message says SCNN, and it means that somebody has connected to the server. Plus, we know its name because at this point, the client that just connected to the server, he already told his name to the server, so we know it, and we can actually start processing it here. Now, what exactly do we need to do when another user has connected? Well, actually, it's fairly simple. We just call user connected again. So user connected, we have the name in a data at index 1. Do we know if it's a host or not? We don't actually know that here. So we are simply going to leave it on false for now, and eventually we'll find a way to define if this is the host or not. And now let's actually give this a try. Right, do we have any debug.log? I don't think we have any debug.log anymore to actually test it out. So what we're going to do is just write a debug.log at the very top of on incoming data, and I'll just say client 2 dots plus data. Same thing on the server side, but this is going to be server. Okay, now let's head back inside of our game and just look at our messages down here. Okay, so at this point the server sends a message to the client receives see who, so who are you client, and then the client replies with I am host basically, and as soon as the server receives that information, he tells the client, well, he tells every client a new person has connected, his name or her name is host. Now let's try with a second instance of the game running, and we're going to be playing with the names a little bit, so let's actually test out our field here. We didn't really test it out. So I am host. I am host, that's fine. Same messages as always. And now as far as the client goes, we are going to connect. And then we get a message, server, so the client sends a message to server, I am Nurkmine, and then everybody else knows that this person has connected. Alright, so we have a list of who's connected. We know when somebody's connecting. At this point, what I'd like to do is just grab the two first player who connected and actually start a game with them. After that, we might create some kind of spectator mode. That's going to be something really simple to do. But right now, what we want to do is just start a game. Now, there is one place where we actually know if there is more than two player, and it's over here in the user connected. Because if you just log in and there's already user connected, you receive them, and if you just connect yourself, well, you receive the user connected as well. So eventually all the players are going to be added inside of this here. So what I will be doing here is we'll be calling a change scene basically, but I don't want to be calling it from the client because that sounds weird. So I'll go inside of my game manager instead, and since we have an instance up here, we'll be able to call it without any problem, and we'll just do using Unity engine .scene management. At the very bottom of my script, or pretty much anywhere, doesn't really matter, I'm going to be creating a public void start game or something like that, and we're going to be booting the game. The way we're going to do this is with a scene manager, load scene, load the game scene. As simple as that, and we're going to be doing that in the user connected. So if players.count is equal to 2, then let's say game manager dot instance start game, and we are going to give this a try really quickly again. Just going to build this with a Control B. Let's boot the game and have a look at this. So I'm going to be hosting here. Nothing happens if I just press on host, but as soon as somebody else connects, both scenes are being sent to the actual, the checker scene. But now, right now, we have one more problem. Both scenes are the black player. If you have a look up here, under board, is white is equal to false, which is also the same exact thing for this guy. So nobody's really able to move because nobody's the white player right now. So we need to know who exactly is the host, and when we have that information, we can go ahead and just say, okay, so you are the host, you're going to be starting with the white pieces. And after thinking about it a little bit, the only place where we really know if the client is a host is when he creates the hosting thing. So if we go back over to the game manager, I believe, we have the host button over here. And whenever you press on the host button, you create a client as well. Now, client, do we have a is host in here? We don't have a his host, so we're going to create one inside of the client itself. Private bool, actually let's keep it public this time since we need to toggle it from somewhere else. So public bool is host, and it's going to be false by default. Now, however, if you are over here in the host button, then you know that is host is actually true in this case. And now the client is going to know whether he is a host or not. And having that information, we can now send it back to the server when we connect. So at this point here, we send our client name. We're also going to send something else, which is going to be, in this case, since we can't send a true or a false, we're going to be casting the boolean as a int. And after the pipe, we are going to say, if we are a host, so if host, we're going to say, if that's the case, 1, and if it's false, 0. So as simple as that, we should actually have this working. Why is it not working exactly? Cannot convert a string to boolean. Okay, so we just have to wrap this around one more time, I believe. Then we're going to get a int, which we can cast as a string. So this is actually supposed to work. We are going to give this a try because I'm not sure if it is. And what we should get when we ask if this is a host or not is actually this here. So 1, that means this is a host. If we boot another instance of the game and somebody's going to connect, we are going to get 0 instead of 1. Let's give this a try. So we're hosting, that's us, we are the host. Now this guy connects and he is 0. Okay, so with that information we can then tell who is the host or not. So now we're sending that information, but we also need to read it on the server side. So let's go on the server, and when we get the message that says see who, we get the client name, that's fine, but after that we get something else. We get the we also know if it's a host or not. So C is host. In this case we're gonna need to keep it here as well. So public bool is host, and we can read it in the second index of a data. So is host is going to equal, and now you do a check. So if the data we get, so if a data, the index 2, is equal to 0, that would mean, well, it's actually a string. So like this, if we get 0, that means it's false, and if we get something else, that would mean it is true. And like this, the server actually know who is the host now. Okay, but we don't actually need that. This is only for good practice, so we can ask the server who is the host. That would work. But what we really need to do at this point is once we enter our game, let's go in the checkerboard. That's like our game manager. So inside of our checkerboard, in the start, we are going to check whether our player is a white player or a black player. So what we're going to do is we are going to check for the client. So let's grab our client. So client C is equal to find object of type client. And really all we have to say here is say is white is equal to C.isHost. And that would be pretty much it actually. Let's give this a try now, see if we can actually at least move one piece in the board. And if we can, it means our function is working. So let's host, say on this side this time, let's switch things up a little bit. We're not going to get everything in the console since this is a standalone, but let's host via this. It asks me for access, sure. And then connect. This is now the black player, and this would be the white player. As you can tell now, we're able to move on this side, but not on this one. So it is working. Now the only thing that we really have to do now is just make sure that whenever we do a move, it's actually sent to the other player. And that would be one of the most complicated thing if we really just built this without thinking about multiplayer. But when we made our game, we actually planned this out a little bit. So we have the function right here that is called try_move. And by calling try_move, you should have your things moving in the screen without even having to select the piece first and I'll do all the kind of stuff, because the select piece is being done over here. And that's really it, to be honest. Let's go ahead and just start looking at our client a little bit. Should we start with the client side? Okay, so we are going to send a message using our client. We're going to send a message every time we end our turn, which means we've moved our things and we can now end our turn. Once we are done with our turn, then we're going to go ahead and just move something on the other side as well. We're going to move the player on the other screen as well. And to do that, I'm actually going to keep an instance of that client because this checkerboard needs to know who is his client now. So we'll do private client. I'll just call client. And we'll change that up here. Just say client is equal to find object of type. Then client is host. Now, whenever we do end our turn, which is over here, I believe, when we end our turn, before we actually scan for possible move, we are going to just start building up our message and send it. Now, the message we're going to create is going to be our move message. So that is what you're going to be seeing directly in the server. So we are the client, we're sending this. Let's call this cmove and add a pipe to it. Then message, let's do plus equal start position, so start drag, in this case .x.toString, and we're going to split this with another pipe, why not? So split this with another pipe, and then the next one is going to be the end drag, no, actually the start drag y. After that we're going to go with the end drag .x and end drag .y, and we don't need the final pipe here. Now, is this going to work? Yes, this is going to work, I believe. And I'm just thinking the toString might actually add some decimal to it, and that would kind of sucks, but I'm not sure it will because we know that those are whole numbers here. Anyway, so once we're done creating our message, let's actually send it by doing a client send, and we're sending our message. As simple as that. That's really all we have to do, by the way. Nothing else is needed here, I believe. Or actually, you know what? Yeah, this is at the wrong place actually. Let's put that beneath our message because we're using start drag in these calls here. So let's make sure we create our message first before we reset those values. So inside of the server on incoming data, we'll create a new case for cmove. And now what we get at this point is we just have to resend the message we've got. Since we can't really communicate directly to the other player, we have to talk to the server first. Well, all we really have to do at this point is just take the function take the message we've created and just send it back to the client. And now we're going to broadcast that data to the actual client. And now we could go and just write the whole thing. We could say smove bracket plus a data at index 1 plus, you know, do all that kind of stuff again and again and again. But what I'm going to do instead is just simply hack this a little bit. I'm going to take my data and just replace the first character. So in this case, the first character would be the old char. That would be the C in this case. I'm gonna replace C with S. So instead of getting cmove at the beginning, we are going to get smove on the other end. And then I'll do broadcast data. Then let's break. And that should be it. So broadcast does not work like that. We're going to broadcast to everyone. And that is pretty much it. So we receive that information from the single client and then we send it back to pretty much everybody. And let's go ahead and just see our client now. In our client, we get a new message. The message is smove. And when we get the message smove, we have to parse it just a little bit so we can call the try move function. Now, do we have access to the try move function? I believe we made it public. Okay, so it's actually private here. Let's make this public because that's you know, that's the one we need to call when we need to actually do something multiplayer. So this one is now going to be public. Let's go back in the client and we're going to do checkerboards instance. Nope, not instantiate, instance. Do we have an instance for that? I don't believe we do. So let's create one really quickly. A public static checkerboards instance. Set get, and instance is now going to be set in the start. So instance is equal to this. Now back in our client, checkerboards.instance try move, and we're going to try moving. Now we have to send all the information we get. So the first one is the first parameter we get. So that's a data 1. So int.parse a data 1, just like that. And we just do that again and again and again until we have all our parameters. So let's just make sure everything is written properly. And that's the third one. And finally, the fourth one. Just like this, we should be able to actually just, you know, try moving our character. Now I'm going to give this a try using both builds. So let's build this, press and play. And we are going to have a look at the results. So we're going to be hosting on this side and connecting on this one. So this is the host, can move the white players, that's fine. If we're back here, we didn't actually move, so there's something not working at the moment. But we are actually able to move black tiles now as well, which is kind of weird. Let's actually go see why. Okay, so for some reason I've kept the calls we had to just swap this every single turn. So every turn you would swap, and it would actually change the color of your player, so you can play by yourself. But I mean, it's not something we can do now. So at the end of end turn, I believe we have this call is white is not equal to white. Let's just mute this. We don't need this anymore, since we actually have two players to play with. And that would be the moment of truth. So let's connect with this guy. Who's the host already? I think this one is. So that's the host. Over to this side, nobody received a call, so that kind of sucks. But as you can tell down here, if you just have a look at the console, we did send a message. I think that was right. So that's 1, 2, 3, 4, 5, 6, and since we're on 0 base, that is 6 over here. And then 2, 0, 1, 2, that's the normal starting position. So 6, 2, that's fine, and goes to 5, 3. So we did get the good information, however, it just didn't go through like we wanted on this side. And I think we're going to be swapping these around, see if we have any errors. So the build is now going to be the client, the host, and then the Unity one, the one that is plugged to my console, is going to be the client. So everything seems to be working. On this side, we're going to try and move. We received the message, but we didn't do the move. And I'm just seeing why down here. So basically, we are in the client. I've double clicked on that. We are in the client. The message we get is cmove2213. But since we're on the client, the message we're receiving is actually from the server. And I think like my little hack I've done didn't really work, because we're supposed to get smove instead. And that, like I said, that didn't work. So let's go back to our server really quickly, and we're going to replace what I've done here. Instead of doing this, we are going to just do the whole thing, like the whole big thing, in a single broadcast. So let's go ahead and just say we're going to be sending smove bracket plus a data at index 0 plus pipe sign a data the index 1. Oh, sorry, this is index 1 here, and this is index 2. Index 0 of a data is actually the cmove. And then we just keep going like that until we have all the parameters we need. So a data at the index 3 plus pipe, and we have one more to do, a data at the index 4. That should actually work just fine now. Let's give this another try. Okay, so the guy on the right is the host, and this is not the host. Moving this here, and as you can tell, we finally got our move on this side. That is very cool. Plus, we also were able to move on the black side here, because we're not the host and we're the black player. This side, nothing happens. We're just waiting for the other player. And then here we go. We just move this. As you can tell, it worked both sides. Let's try to kill something. We're able. It's no longer our turn. We go on this side. Not able to move this. Not able to move this because we have to kill something. So we're able to move this guy. We're able to move this guy. The game still works exactly the same as when we created in the single player. And finally, the last thing we need to do is to end the game is to make sure our check victory function works. Now, the check victory function, I've tested it out on myself. It doesn't seem to work right now, and I've just figured out why just recently. Basically, is we check for victory by looking at all the pieces on the board. Now, if one of those pieces, if all the pieces are the same color, then we just do a simple condition here. Everything seems to work theoretically, but when we actually play the game and we win, nothing really happens. And the reason is because when we kill a piece, we call a destroy on it, which is something that is going to destroy the piece, destroy like the object on the next frame. And at this point is what happens is during the same exact frame, we destroy that piece and then we check for the victory. So we do this victory check, but it's never going to work out because even when we destroy that piece, there is still, say, a minimum 2 pieces remaining, one for each team. So what we need to do is actually destroy that piece immediately. So right now I'm just trying to figure out where exactly we destroy the piece. I think it's somewhere in the try move. So in the try move here we do a destroy. Now instead of doing destroy, we're going to do destroy immediate. And we are going to quickly just try out this function. Now I've also modified my game a little bit, so it only spawns one of each piece, and it helped me test out basically. So I'm quickly going to check it out using my setup here. Let's connect, and as you can tell, there's only one piece being spawned. That's modification on my end just to see if this works or not. And we're gonna move closer to this guy, and when we do win, we should get the message at the very console, at the very bottom of the console that says either player has won, and it says right here white player has won, which is true because there's only white pieces left. So now our victory function works, and that should be pretty much it for the game. So guys, that is going to be pretty much it for the whole mechanic of the game, just having multiplayer works. Now there is a lot of polishing to be done so we can actually make this look good, but all the basic function are done, all the basic communication are done, and we should now be ready to go to just add some polishing to it. Just add, I want to add the camera system, just put it in there, have some kind of really nice intro screen, you know, a lot of good stuff can come out of this if we just give it a little bit of time after making the game work, of course. So thanks so much for watching, guys. Stay tuned for the next few episodes. As always, leave a like on the video if this helped you or if you enjoyed the tutorial. Also leave a comment, that also helps out quite a lot. Facebook would be very cool if you just follow that page, check out the Patreon page. There's a lot of stuff you can do to help me out, make more tutorial and make more courses. All the links are in the description below. And as always, guys, thanks so much for watching, and I will be seeing you in the next one.